Hello everyone, let's do another quick demo with the Cryostat 4.0 release about to come up. If you haven't already seen my previous video about the Cryostat 4.0 Operator Agent Autoconfiguration and the console plugin, I highly recommend you go back and watch that video first. That'll give you much more context into what we're starting with right away here. So we can see on the left hand side, just like the last demo, I have our admin perspective on this console, looking at the Cryostat plugin on the Cryostat topology view. On the right hand side, we have the console developer perspective with the console topology view. And I've already gone ahead and created and run a build for this basic Code with Quarkus starter application. Scaled it down to 0 for now. And I've gone ahead and already edited my deployment spec template metadata labels to add the same two that we're familiar with from last time, the name and namespace. And I've added one more new one this time, which is this harvester template. So if you're not familiar with what this means, JDK Flight Recorder, normally in your Java application, will come with at least 2 predefined event configurations or event templates. You can find them in your application image. It's under user libjvm and then the path to your JVM, libjfr, and then you should find 2 files named like default.jfc and profiling.jfc. They're basically just XML files that define which JFR event types are enabled and some settings for each of those events. At the top of that file, you'll find that the sort of root element has a field called label, and that label is what we're using here. So continuous here corresponds to the default .jfc file template that comes with this Quarkus application JVM. A bit of a long-winded explanation, but anyway, that's where this value comes from. What this means is that when our Cryostat agent instance starts and hooks itself up to this application, it's going to begin a JFR recording, a flight recording, right away using this event template, just right away out of the box. So let's go ahead and scale this up, and we should see it register itself and show up within Cryostat pretty much right away. So there it is. And let's actually scale this up and give ourselves a second pod. So what we should see is that once that scales, it should show up here. It's a little overlapping, so there it is. Second instance there right away. Let them run for just a minute while I explain this next part. So the harvester functionality allows us to do something that's kind of like what the OpenJDK JFR system can do on its own when you're running on bare metal, which is when your JVM exits, if it crashes or something happens, the JVM can write that JFR file to disk so that you can capture the data about what was happening in your JVM right before it exited, and you can go back to that for later analysis offline. Obviously here when we're running an OpenShift, that functionality is still there. You can still configure your JVM to dump a file on exit. The problem is usually these pods, they have just ephemeral storage, and so wherever the JVM is going to write that file, it'll get dumped out to disk, and then the pod gets cleaned up, and that file gets basically garbage collected by OpenShift immediately, and we can never actually get access to it. So the Agent Harvester, Cryostat Agent Harvester, lets us do something similar. What will happen is the harvester can intercept signals that your JVM receives, and it'll try to add a hook to upload your JFR data to the registered Cryostat instance as part of an orderly shutdown. So now that I explained that, and we've seen this is running for a little while, let's scale this down and see what happens when one of our pods is going to exit. Okay, so immediately we see this notification that an archived recording was uploaded. So let's jump over to our archives view. That target has already disappeared, so it's not under the All Targets tab. We have to go to All Archives. And here we can see, this is the JVM ID. If we expand that table row, we can see some information about what that JVM was. And we can see there was an emergency push, so that means that this was pushed because the JVM was exiting. And we have a JFR file. And so we can do automated analysis and we can view this file in Grafana to try to figure out what was happening to that JVM at the time that it exited. Obviously, in this case, it's not too interesting because we just scaled it down, so nothing was really happening in the JVM. But you can imagine that maybe it was killed because it became non-responsive. Maybe you have a deadlock or some resource contention, and the pod was no longer responding, so it's going to get scaled down. And you may be able to trace the root of that issue in your JFR data. And so this is a quick demo just to show how you can capture that data quickly and easily, and make sure that you can always grab that sort of tail end of JFR data from your applications with just adding one more quick label to your applications. Okay, that's it. Thanks for watching. Have fun.